In this video, we are going to integrate Lambert W function. We have this integral from 0 to e, Lambert W of g dz, where Lambert W of g is Lambert W function. So, to integrate this, uh, we are going to use the property that if f of x is x e to the power x, this is basically a definition and then property. F inverse x is defined as Lambert W function of x. So this is the definition of Lambert W function. Since we basically cannot take the inverse for this function, Lambert W function is defined, and for this we can have series expansion. So it basically makes sense to define it, because if you want to evaluate those values, you can put it in series. For example, if you want to solve 2 x e to the power x, so basically our value will be Lambert W of 2. Our answer will be this for x. And then we can just use series expansion of Lambert W and then solve for x. So that's how it helps, because we cannot directly solve it. We have defined this function and we have a series expansion for this function as well. It also has some integral representations to evaluate the value. Okay, and this is also known as product log function. Yeah. And now let's see how we can solve this integral. For this, we have a property of integral for inverse function, which says that integral from a to b f of x dx plus integral from f of a to f of b f inverse x dx is equals to b times f of b minus a times f of a. So we will use this property. Since if we have f of x as x e to the power x, we can evaluate this integral, we can evaluate this thing, and here f inverse x is Lambert W of x, and we will get the value by subtracting this integral from this value. Okay, so we are going to use that. And first, to see why this is actually true, you can just follow some geometric approach. Let's say if we have a function f of x like this, and its integral from a to b will be just this area. Yeah. And its integral from f of a to f of b f inverse x will be, here we have f of a, and here we will have, corresponding to this value, we have f of b over here. This corresponding to this value f of a, corresponding to this value we have f of b over here. Now for f inverse of x graph, we can just see this axis. We are just running in this axis now, and from f of a to f of b. So this area will just be this area. And now to find this area, we can find area bigger rectangle minus area smaller rectangle. So that's area bigger rectangle is length into breadth, that's b f of b. And the smaller rectangle is again length into breadth, that's a f of a. So that's how we derive this formula. And now we will use this. So here our f of x is x e to the power x. Okay. And f inverse x is Lambert W of x. So we want f of a and f of b to be 0 and e. Yeah. So for f of a, here f of a, that is a e to the power a to be 0, we actually need a to be 0. Yeah. And for f of b, that's b e to the power b to be 1, we need b, no, not 1, it's e. Yeah, e. To be 1, e, we need b to be 1. So we have the values of a and b now. So what we can do is we can just integrate this from 0 to 1, that's a equals 0 and b equals to 1. F of x is x e to the power x dx, and from f of a to f of b, f of a is 0 and f of b is e, and f inverse x is defined as Lambert W of x, and here b f of b minus a f of a. B is 1, f of b is e, minus a is 0, f of a is 0. So that's just e over. Now you can see how we will proceed. And we can also integrate it by integration by parts. First of all, x as our u, e to the power x as our v, and integral of e to the power x is just e to the power x, minus integral of derivative of x is 1, integral of e to the power x is e to the power x dx. Okay, and then over here we have the same thing, and over here we have e. And for this integral now, x e to the power x minus, it is just e to the power x, integral of e to the power x. And this is evaluated from 0 to 1. And yeah, integral from 0 to e, Lambert W of x dx is equals to e. Now if we evaluate this, at 1, here we have e minus e, minus at 0, we have 0 minus 1, plus integral from 0 to e, Lambert W of x dx is equals to e. Okay, let's proceed further. E and e cancel out, and negative of negative 1 is just 1, plus integral from 0 to e, Lambert W of x dx, this is e. And now you can take 1 to other side to get integral from 0 to e, Lambert W of x dx is equals to e minus 1. So we have the solution now. So basically, we were lucky that our limits of integration were such values that we could find the values for a and b. Yeah, so that's what made our integral easier, and that was chosen by b specifically. But what if those values were such that we couldn't have easily found out the value of this a and b? What we would do in the such situation? So you can basically use the series expansion of Lambert W of z. Yeah, here we have the series expansion of Lambert W of z. Lambert W of z equals to summation from n equals to 1 to infinity, negative n to the power n minus 1, and x to the power n by n factorial. So if we have to integrate this from a to b, Lambert W of z dz, we can basically do it like this. We can basically integrate its series, n equals to 1 to infinity, negative n to the power negative n to the power n minus 1, x to the power n by n factorial, and then we can change the sum and the integral, and then we can proceed. So I leave it on you to find this integral 0 to e Lambert W of z dz by using this series expansion. Do give it a try and share what you have in the end, what we get in the end with me in the comment section. So I hope you got the explanation, and I hope you understand the solution. So thanks for watching. See you in the next video.